Hello my dear students, my today's video is based on multiple choice questions on the chapter relation. The question number 1, the first question, the smallest equivalence relation from the set A to A where A has elements 1, 2, 3 is, we have got 4 choice. First choice has got elements 1, 1, 2, 2, these are order pairs 1, 1, 2, 2, 3, 3. Second 1, 1, 2, 2, 3, 3, 1, 2, 2, 1. Third 1, 2, 2, 1, 1, 3, 3, 1. Fourth 1, 1, 1, 2, 2, 1, 2, 2, 3, 2, 2, 3. Now before I go straight away into the answer, I like to tell you what is an equivalence relation. Now we know what is an equivalence relation. An equivalence relation will be that relation which will be reflexive, which will be symmetric, and which will be transitive. If any relation is reflexive, symmetric and transitive, then it will be an equivalence relation. Now, if I consider A an element which belongs to A, then if it is reflexive, then A comma A must belongs to R, the relation. That means every element, since A has got element 1, 2, 3, then this type of relation, this is called identity, AA, same. 1 AA must belongs to R. That means for this relation, for this element, say 1, 2, 3, 1, 1, 2, 2, 3, 3 must lie on the relation. So in this case, we have 1, 1, 2, 2, 3, 3. Here also we have 1, 1, 2, 2, 3, 3. Here also, here we don't have. Here 1, 1 is there, 2, 2 is there, 3, 3. So we can straight away delete C and D, not possible, because it is cannot, these two cannot be a reflexive relation. Second is symmetric. If I consider, if A comma B belongs to R, the symmetric relation says that if there is an ordered pair A comma B belongs to R, then B comma A will also belongs to R. Means if 1, 2 exists, then 2 comma 1 also should exist. What is transitive? Transitive says if A comma belongs to R and B comma belongs C belongs to R, then A comma C must be belongs to R. If A and B belongs to R, B comma C belongs to R, then from this two what we get? A and C, A comma C, the order pair A comma C must belongs to R. So let's check. So I have checked already, this relation is this one and this one, both are reflexive. Symmetric. See 1, 1 reverts A comma B, B comma A. So 1, 1 is there, 2, 2 is there, 3, 3 is there. This one, 1, 1, 2, 2, 3, 3. This condition I am not getting. I am getting AA. There is a relation, always remember, in case of this, if A comma B belongs to R is given in the relation, but you don't see B comma C. B comma C is not there in the relation. If such cases arises, then we say, we don't check for transitive. We say straight away that that particular relation can be a transitive relation. So this relation is acting as reflexive. This is supporting symmetric, and this is supporting the transitive relation. Here 1, 1, 2, 2, 3, 3. So this is definitely reflexive. 1, 2 reverts 2, 1. So definitely symmetric. 1, 2, 2, 2. So A comma B, B comma C. So we get 1 comma 1 is also lying. That means it is supporting transitive. So this is also equivalence. This is also equivalence. Both are equivalence. Now which one will be my answer? The question is asked the smallest equivalence relation. So this has got 1, 2, 3, 4, 5 order pair, and this has got 3 order pair. So this is the smallest. A is my choice. We'll move on to the next question. So my next question, question 2. Let A is equal to a set containing 4 elements A, B, C, D. Then the number of relations from A to A is 4 choice. 2 to the power 4, 2 to the power 8, 2 to the power 12, 2 to the power 16. So this A has got 4 elements. So number of elements which we denoted by n. So n is 4 here. We have to find out number of relations from A to A. How many relations are there? The formula for this is number of relations from A to A is equal to 2 to the power n square. That's the formula. 2 to the power n square. N. What is n? N I told number of elements in the set. So there are 4 elements. So n is 4. 4 square means 16. 2 to the power 16. So D is my choice. We go to the next question. So next question. Question number 3. Let A be a set of all students of a boys' school. Then the relation R in A is defined by R is equal to a set having ordered pair A comma B such that A is sister of B. A and B are the 2 elements. A is a sister of B. Is 4 choice. A, an equivalence relation. Second, a symmetric relation. Third, an empty relation. Fourth, a universal relation. Now let us understand this 4th choice first. I have already discussed what is an equivalence relation in my first question. So an equivalence relation is that relation which will be reflexive as well as symmetric as well as transitive. What is a symmetric relation? A symmetric relation is that relation in which if I have the order pair A comma B, then B comma A will also be there in the R relation. What is an empty relation? Empty relation will be that relation which will contain no elements. No order pair will be there. Nothing will satisfy the R. What is a universal relation? Universal relation is that relation which will contain, where the relation R will contain all the element of A cross A. That means the order pair A cross A, whatever order pairs are there, all the order pairs will satisfy the universal relation. So here it is said it is a boys' school. And it is said A is a sister. So in the school there is no girls are there. Since there is no girls, so this will be a empty relation. So C is the choice. So the next question, question number 4. If a relation R on set having 3 elements A, B, C defined by R equals to set order pair B comma B, then classify the relation as 4th choice. Symmetric and transitive but not reflexive. Only symmetric, reflexive and symmetric, equivalence. These are the 4 choice. Now the set has got these 3 elements. So if I say A is the set, then it has got 3 elements. A, B, C. Now if this relation has to be reflexive, then the relation must have A, B, B, C, C. That is what we said, that for reflexive, for all the elements, it must have, for all the element, order pair must be there, identity order pair, A comma A, B comma B, C comma C. So this is my R given. R is given B comma B. So that means AA and CC is not there. So the question of reflexive does not arise. So that means this cannot be. This cannot be equivalence because it is not reflexive. Now, BB is given. If BB is given, that means if I do reverse, BB, if I do reverse, then also it becomes BB. That means it is obeying the symmetric property. So it can be symmetric. So it can be symmetric. It can be this. Again, I have told you that if A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R. If this happens, then that is transitive. So I got B comma B, which is obeying symmetric condition. So will I say that this relation is only symmetric or it can be transitive also? So as it is said, as by law, if AB is there and BC does not exist, if B comma C order pair is not there, then we can say that this particular order pair supports transitive property also. That means this order pair B comma B will not only be symmetric, it can be transitive also. So it will be symmetric and transitive but not reflexive. So A is the choice. We go on to the next question. So the next question, question number 5. Total number of equivalence relations defined in the set R is equal to, has got 3 elements, 2024, 2025, 2026 is, first choice, 2 square plus 1. 2 square plus 1 means 4 plus 1, 5. Second choice, 3 factorial. C, 2 cube. D, 3 cube. We have to find out with these 3 elements how many equivalence relations are possible with this. Since these numbers are quite big, 2024, 205, 2026, I am considering this as A, this as B and this as C. Right? So with 3 elements A, B, C, what are the equivalence relations? I'll write all the equivalence relations. First, this is one of the equivalent relation. This relation is my identity relation. This relation is called identity relation. What are the other relations possible? AA, BB, CC, AB, BA. This is also equivalence. AA, BB, CC, BC, CB. This is also symmetric possible. AA, BB, CC, AC, CA. This is also symmetric possible. AA, BB, BC, CB, AC, CA, CC, AA, BB, CC, AB, BA. This is also equivalence relations. All these are joined together. Universal relation. So 1, 2, 3, 4, 5. So 5 equivalence relations are possible having 3 elements A, B and C. So A is my choice. We go to the next question. So the next question, question number 6. If A is equal to a set having elements alpha, beta, gamma, delta, phi, 5 elements, then number of reflexive relations from A to A is 2 to the power 20, 2 to the power 25, 2 to the power 30, 2 to the power 55. We need to find out how many reflexive relations are there from A to A. Now here how many elements? 1, 2, 3, 4, 5, 5 elements. So here number of elements, that is n, is equal to 5. Number of reflexive relations, number of reflexive relations is equal to 2 to the power n square minus n. This is the formula. 2 to the power n square minus n, where n is the number of elements present in the set. So in this case, n is 5. So I'll put here 5 in place of n. So 2 into 5 square, 5 square is 25. 25 minus n, n is 5. So 25 minus 5, that is 20. 2 to the power 20. So A is my choice. Hope you have followed. We'll go to the next question. Now the next question is a very tough question and must pay attention to this particular question. The question is, the domain and range of relation R is equal to set having order pair x comma y. X and y both belongs to natural number and x plus 2y is equal to 5, this is the condition which is satisfying, is four choice 1, 3, 2, 1. So the 1, 3 is my domain, 2, 1 is the range. Second choice 2, 1, 3, 2, 1, 3, 1, 1, 1, 2, 1, 3. Now if we try to find out the domain and range, it is given x and y both belongs to natural number, and the equation which is satisfying, it is given x plus 2y is equal to 5. So we can say x will be equals to 5 minus 2y. So we'll try to find out the value of x for different value of y. So if I take y is equal to 1, so if I put y is equal to 1, so 5 minus 2 into 1, so value of x comes 3. 1 is a natural number, 3 is a natural number, so both x and y belongs to n. If I take y is equal to 2, if I put 2 to the 4, 5 minus 4, x is equal to 1. Both 2 and 1 are natural number. Both x and y belongs to n, natural number. If I take y is equal to 3, 3 to the 6, 5 minus 6, x becomes minus 1. This is not a natural number, right? So this, because as per the condition, the x and y both must be belongs to natural number. So only two order pair is satisfying. One is 3, 1, another is 1, 2. 3, 1 and 1, 2. These are the two order pair which is obeying or satisfying the condition x, y belongs to n. So the relation will have these two order pair 3, 1, 1, 2. 3, 1 and 1, 2. So domain of the function will be what? Domain of the function is the first value, the first components are domain. So 3 and 1. If we write it in order, so first comes 1, then 3. This is the domain. And the range of the function will be the second components, that is 1 and 2. Since I have written 1 first, so 2. So this will be 2, 1. So 1, 3, 2, 1. 1, 3, 2, 1. A is my choice. Go to the next question. So our next question is question number 8. If A is equal to a set having element x, y, z, then number of symmetric relations from A to A is choice 2 to the power 5, 2 to the power 6, 2 to the power 8, 2 to the power 10. We have seen, we have discussed questions where to find number of relations, number of equivalence relations, number of reflexive relations, and now this question is how many symmetric relations can be formed. Now see, here n is how much? Number of elements. Number of elements, that is n is equal to x, y, z, that means 3. Therefore, number of symmetric relation is equal to 2 to the power n square plus n by 2. 2 to the power n square plus n by 2. Here n is 3. So we'll put 3. 3 square, 9. 9 plus n is 3. So 9 plus 3, 12. 12 divided by 2, that is 2 to the power 6. So B is the choice. We'll go for the next question. So the next question, question number 9. Let us consider a relation R on the set of integers Z on R is equal to set order pair A, B such that A minus B is divisible by 3 and A and B both belongs to Z. Given R is an equivalence relation, then the equivalence class of 0, we write like this equivalence class, is 4 choice. So the equivalence class of 0 is equal to minus 6, minus 3, 0, 3, 6, like this. This will be minus 3, minus 1, 0, 1, 3, 5. minus 6, minus 4, minus 2, 2, 4, 6, and none of this. So we need to find out equivalence class. What is given here in this question? It is given that the relation is on Z, that is the integer. So R is defined on Z. Z, that is the integer. Such that this order pair A comma B, this A comma B belongs to R. And not only that, A comma B will belongs to R if A minus B is divisible by 3. A minus B is divisible by 3. This is what is said. Is divisible by 3. And A and B, they belong to Z. Since I need to find out the equivalence class of 0, that means which are the values that will satisfy? That means I'll consider this B, I am finding out the equivalence class of this number, that is 0. So A minus 0, I should look for A minus 0, which will be divisible by 3. I am finding out the equivalence class of B, that is 0. So B is 0. So I should think about those set of values where A minus 0 will be divisible by 3. So any number will be divisible by 3 provided it will be multiple of 3. So the numbers has to be multiples of 3. See, in this case, these are not multiples of 3, these are not multiples of 3, so this choice cannot be. In this case, these are not multiples of 3, so this choice cannot be. So multiple of 3, see, have a look at this. This is 6, minus 6 minus 0, minus 6, divisible by 3, minus 3, 0 is minus 3, which is divisible by 3, 0 minus 0 is divisible by 3, 3 minus 0 is divisible by 3, 6 minus 0 is divisible by 3. So this, all these values, they will satisfy this condition, A minus B divisible by 3. That means, since it is said R is an equivalence relation and we need to find out the equivalence class of 0, so only those values which will satisfy A minus 0 and which is divisible by 3, that means A, which will satisfy all these conditions as per the given question. So A is my choice. So next question, question number 10. Intersection of two equivalence relations is always a reflexive relation, symmetric relation, transitive relation, equivalence relation. Fourth choice. You got to find out that intersection of two equivalence relation is what? What exactly the question is meaning. So if I consider P and Q, P2 relation, and if A is any set, this P is equivalence on set A, and the set Q, this is also equivalence on set A. Both of them are equivalence on set A. Intersection of these two sets, that means P intersection Q. You have to prove that P intersection of Q will be what type of relation? Reflexive, symmetric, transitive, or equivalence. So P and Q two sets. P reflexive with A, equivalence with A, Q is also equivalence with A. Intersection of these two sets, P intersection Q is what type? The answer will be, it will be an equivalence relation. I am not showing you the working. I am giving this to you as a homework which you try. How can I prove that P intersection Q will be an equivalence relation? If you are finding it difficult, then do comment in the comment box, and in my next video, I'll show the solution of this particular sum.